Could you imagine mining for gold and throwing away silver? Oil and gas wells in the Bakken Shale do this every day. They drill for oil and throw away gas. They waste over $100 million worth of natural gas every month. At Detonation Dynamics, we believe that energy should be used efficiently to build sustainable societies, and we aim to convert wasted resources into electricity. I'm Raheem, and I'm CEO of Detonation Dynamics. Presenting with me today are Manuel and Alia. From speaking to several of our customers, we consistently find that their primary pain point are high operating costs. Let us take, for example, the oil and gas well operators. They currently use diesel generators to provide energy for their fracking, drilling, and production operations. At some of these wells, they also flare gas. This is where we find a tremendous opportunity for our technology. A detonation generator, or detogen for short. Our detonation generators can operate on both diesel and natural gas. These engines can provide energy for the oil and gas operators. Also, these engines will be able to use flare gas, thereby drastically reducing the operating cost of the oil and gas operators by more than 40%, allowing these engines to be able to pay for themselves within a year. That was a demonstration of a pulse detonation engine. Because of their promise of performance and efficiency, the Air Force has performed a flight test as recently as 2008 to be able to replace jet engines with pulse detonation engines on aircraft fighters. Also, in 2015, the Japanese Space Agency plans to perform a pulse detonation rocket engine test flight. Our proven technology has been developed for over 20 years by Dr. Frank Liu, a member of our team. By using our pulse detonation engines that convert the energy of fuels into wave motion, and our linear power generators that convert oscillatory motion into electricity, we've brought you the Detogen, a single piston engine that converts the energy of fuels into electricity. Currently, no detonation engines exist in the marketplace. Our technology is protected by several patents owned by the University of Texas at Arlington, and we plan to license these technologies to be able to sustain our competitive edge. You might be wondering, how does this solution stack up to current existing solutions in the marketplace? I will allow Manuel to address that.
Thank you, Raheem. One of the important questions to ask when we are thinking about our competitive edge is, why would our potential customers choose us? Why would they buy a Detogen from us? As you mentioned, one of the consistent pain points that we find for our customers are the high operating costs. Here you have a comparative chart of the two industry solutions, which is a diesel generator and a gas turbine, compared with our Detogen. And as you can see, the diesel generator has a much higher operating cost than a gas turbine, which comes in at $77. Now you might be saying, well, why don't they just switch to a gas turbine if it's so cost efficient? Well, the problem is that whenever an oil well is being dug, what they do is they bring diesel generators to provide the energy for the power, for the equipment that's doing the drilling. When the extraction begins, it's not feasible to change to gas turbine because it's costly and because of the inefficiencies of that system. This is where we find, again, our opportunity. By providing the biofuel solution that will be able to provide energy during the drilling phase, when they're running the fuel diesel, and then switching over to natural gas once the extraction happens throughout the life of the well. Now, it's important to realize that our detonation generators can detonate any mixture of gas, which the current market solutions have to go through a filtration system or different type of technologies that cost $1.5 million. Also, we are more efficient at detonating the fuel. As you can see, the diesel generator comes in at 40 and the gas turbine at 30%. And because of, Raheem mentioned that it's a single piston engine, it is less maintenance because it has less moving components. The gas turbine comes in at a very high maintenance because of its, the rotary components that are within the system. It's also important to note that these systems operate at Tier 2 standards. Currently, any engine or generator that's out there will operate in a Tier 2, which is the EPA standard level of emissions. We can bring that down to a Tier 4, which is much lower than any current industry standards. Also, important to note that you achieve this 40% and this 30% operating at full capacity. What that means is that, let's take for example this 300 kilowatt unit, it would have to operate at 300 kilowatt full capacity to be able to pull 40% efficiency and 30% for the gas turbine out of that fuel. We can achieve those percentages at any capacity. We can run that generator at 150 kilowatts and still achieve a 55 and 50 for diesel and natural gas. Now you might be saying, okay, well, what is your initial target market? Well, we've found that the back and shell formation is especially, it's ideal for us to go after for several reasons. They spend $3.6 million a day in wasted of gas, $11 million a month, and 11,000 current oil and gas wells are operating at the back and shell. 1,800 are being added every year, and at the peak performance of this site, there will be close to 30,000 wells. Our business strategy is to pursue a contract manufacturing business model similar to Lockheed Martin and Boeing, in which the parts will be outsourced and manufactured out of the development facility and then be brought back in and assembled so we can protect proprietary technology. Now you might be saying, well, you just told me my initial market, but what is the potential? The potential is to, at the back and shell, $3.5 billion, at the U.S. market, $558 billion, and in the global market, $1.2 trillion. You might be saying, well, this is great, but these are established players. These are established oil and gas wells. Why would they switch over to your technology if you just told us that they're reluctant to change once they start extracting? It's true, but 2 points why. One, after speaking to potential customers, potential investors, and also energy consultants, we find that the money being spent and wasted in these resources, or in these wasted resources, the flare gas, it's substantial enough for them to actually want to switch to a new technology or explore other avenues. Also, in the U.S., shale gas market is expected to grow 20% in the next 4 years and more than double in the next 20 years. So we want to be positioned where we can offer our clients diesel solution when they're drilling for those wells, and then the gas solution for throughout the life of the well. And it's also interesting to understand that although we initially planned to offer the solution as a low cost or to lower their opportunity cost, their operating costs, we can have the capacity to reduce their flare gas problem considerably. Not only that, but we could also target waste gas industries, such as waste management and agricultural, which emit methane. Our detonation generators can detonate on methane. Electric utilities use gas turbines, and our technology could potentially replace that. More than anything, if you can think of anything that has an engine, our technology has the potential to replace that at a better efficiency, better operating cost. So auto, trucks, trains, and ships can use this technology. Even manufacturing can take advantage of this technology. Interestingly enough, this was developed for the aerospace. For many years, it was developed for the aerospace industry, and this is the engine that could potentially take us back to the moon. It sounds like a dream, but I'll let Ahalia let you know how that can become a reality.
Thank you, Manuel. We are seeking an investment of $4 million to develop, integrate, and market a detonation generator. As Raheem mentioned, we have exclusive access to several patents at the University of Texas at Arlington. and we will use our initial funding to execute licensing agreements. The development phase also includes building a production prototype, which we will be completed at the end of this year. Further in the development phase, we're going to be building a mobile detergent, certifying it, and pilot testing it at oil and gas sites and advance it to be industry ready. And in the integration phase, we are looking at acquiring a development plant and equipments that would facilitate testing. The marketing phase is about participating in industry-related trade shows that will help us establish relationships with potential customers. And in the next round of funding, we will be seeking commercialization grants and investments that will help us produce 50 detergent engines. Well, why 50 engines? 50 engines is going to give us a profit of $7.5 million, and we will break even at 22 units. All this is calculated considering the $4 million that has gone into the business in the previous 3 years of initial production. Yes, we are planning to launch our first product in the year 2017, and we are looking at a return of investment of 47%. How 50? How are we so confident that we can sell at least 50 engines? As Manuel mentioned, we are looking at an initial customer target of 11,000 customers, and the shale gas boom is going to bring in 2,000 new oil wells. So they're going to require some equipment to power the operations. So when we talk about the technology to them, they are willing to adapt our technology, and they're waiting to adapt to it. And we're talking about a sales growth of 50% afterwards, which means selling 400 engines in the next 4 years after our initial launch. By the time, we will also be concentrating on the US market, which has 1.8 million active oil wells right now. And our exit strategy is going to be acquisitions, because we believe that that is the most rewarding exit strategy for startups. And we're also looking at industry players like GE and Cummins buying our business in the future. All this sounds positive. Yes, very optimistic. However, we understand that we are a startup, and we are also aware of the risks that come to the startups, like sustaining competitive edge. Existing industry players, they're really huge, and also educating customers about a new brand and a new product. The inventor of the technology, Frank Liu, is part of our team. And our technology team has developed many engines similar to detergent. They have also received millions of dollars in grants and investments from industry partners like Lockheed Martin, NASA, Bell Helicopter, and GE to develop proprietary technologies. With this said, we will continue to innovate and make sure that detergent lies abreast of technology in the market. And the business team has marketing and management expertise in the energy sector. On our advisory board, we have Mr. Richardson, CEO of Ringo Drillers, who has agreed to test our detergent engine in his oil well at Bacon Shale. He's also agreed to have our engine run at his oil well after the completion, just to reference to other new customers. So we have a great technology, no doubt about it, but we have an even better team.
We've shared with you our proven detonation engines and how we plan to sustain our competitive edge. With our experienced team and your $4 million investment, we can convert waste gas into electricity at North Dakota's Bakken Shale. Thank you.